For the last few weekends I was trying to build pressure airflow meter based on pitot tube design. My goal was to obtain a stable reading proportional to the difference between stagnation and static pressure inside ventilation duct. In a classic pitot tube, this pressure difference in pascals can be used to calculate flow velocity from the Bernoulli equation. However, in my project, because of tiny pressure difference, I assumed simplification that the output is linear and I will make conversion from sensor data to airspeed in meters per second basing on the known expenditure of fan on which I will test the device. I have decided to buy MPX2053, a sensor with voltage output proportional to applied pressure. For my application, best would be differential version with 2 terminals, but it was too expensive for my budget. Instead, I have chosen gauge version that compares the pressure from P1 terminal on the picture to atmospheric pressure directed through a vent hole on the back side of the sensor, P2 on the picture. The sensor is powered by 10 volts and has 2 output signal pins. Right after connecting sensor to power and multimeter, the first problem appeared. Output voltage at zero pressure difference is only 0.2 mV. It is not zero due to sensor offset. And even after blowing directly into terminal, it does not exceed 1 mV. This is way too low voltage to be read by Arduino analog pins. To make it useful, I will need to amplify it at least few hundred times. After some searching, I found an instrumentation amplifier that met my expectation of precision and was in the budget. This analog devices amplifier has 8 pins and it is surprisingly easy to implement. Placing proper resistor between pins 1 and 8 allow programming the gain of input signals from pins 2 and 3 and pin 6 outputs amplified voltage. In my project I will use the sample scheme for single supply configuration. I only need to connect everything to correct pins, capacitively decouple power source and select the appropriate resistor. I need as high amplification as possible, so I'll use 100 ohm. The first prototype looks hideously, but its only purpose is to check if everything is working. I have connected tube to sensor terminal and placed intake against the airflow inside 125 mm ventilation duct. I left the vent for measuring atmospheric pressure on backside of sensor out of the duct to exclude this factor from test. At zero airflow, the multimeter is showing 539 mV, so I got a lot more amplification than I should. I suspect that raw sensor output was too low for my chip multimeter to measure correctly. I got faulty connection or too much electromagnetic interference. However, even with this makeshift build, all readings were quite stable even after increasing the flow in the duct. At full fan speed, output increased to over 600 mV. This rise will be enough to use with Arduino. Next step will be building more compact prototype with better connections. To reduce interference, I twisted pairs of power and signal wires and created a simple shielding with aluminum foil connected to the ground. In this prototype I placed whole sensor inside the duct in a way that main terminal is facing moving air to measure stagnation pressure and vent in backside is covered from airflow to measure static pressure inside duct. From my previous experiments I know that this fan at minimal controller setting has output of 2.5 meters per second and on maximum setting 7.2 meters per second. Based on this data and sensor reading at different fan settings, I determined the equation for linear pattern. As for Arduino sketch, I wrote a program that is doing 2500 reading in a loop with 1 millisecond increments. Then it averaged them and input result to linear equation. As a result, I got airspeed measurement of full work range of this fan. So this is all for today. Thank you for watching. To the end of the video I will leave this clip where I slowly increase fan speed until I reach full speed. If you think this was interesting, please like the video and subscribe to my channel. If you know what I have done wrong or how I could improve this device, please let me know in comments. I will be posting Arduino code and connection diagram in video description.